Okay, vertex form. So, vertex form of a quadratic is so nice because you can look at it and tell where the vertex is. There's no math to do. You don't have to do negative b over 2a. In fact, you can't because it's not in that form. But if you know how vertex form works, but you will, then you can just look at these things and tell me where the vertex is, okay? So, here's the general form for vertex form. Now, you'll notice some new letters here. We have H and K.
Oh, wait, I have a question. Are they the X intersection of Y intersection?
No, you're kind of close. H comma K is the vertex. So we'll talk about how to extract that in a minute. But then A still tells us everything that it told us before. So it still tells us up, down, wide, narrow, all that stuff. So A is the same. So A still tells us up, down, wide, narrow. So that's no different than it has been. You're going to find all the pieces. It's just to find the vertex is actually a lot easier now because you can just look at it. So let's just take the first example on your worksheet here. So this one. What is A in this example? -2. It's always that first number, that number out in front. Okay, so does everybody see that? A is -2. So because A is -2, tell me, is it up or down? Down.
No, it's narrow. I'm sorry.
It's going to be narrow, right? Because absolute value is 2. So it's going to be a narrow. C. Now, here's the nice part. I get to do this part without doing any math. But for whatever reason, this stumps a lot of people. Let me see if I can get both of these on at the same time. Okay. I know, but I want it to be big enough so that you can still see it. There we go. All right. See how it's H comma K, H comma K. H is the vertex. What number is in there for the H spot?
Or 4.
It's just a 4.
It's just a 4.
Because the formula is a minus, right? Like if I said, hey, plug in a 4 for H, wouldn't you write X minus 4? If you plugged in a -4 for H, it would actually turn that into a plus. So that part seems to be where people mess up. But once you get the hang of it, it's all right. So it's always going to be the opposite of the number that you see right there. Okay, so it's going to be a +4, comma, and then it really is whatever this number is out on the outside here. So my vertex is actually at 4, 4. So again, it's always the opposite of the number that's in there with the X, in parentheses with the X. Opposite of that number, comma, whatever this one is. Whatever the sign is, that one stays. So it's opposite of this one, that comma, that number. That's it. You don't have to do negative b over 2a. Notice there's not, in my form here, I don't even have b and c. I just have a. So if I even tried to do negative b over 2a, I don't know how you would do it without changing this back into standard form. What you could do, but why would you bother? Okay, so just like before, once I have the vertex, I have the axis of symmetry. What is it? X equals 4. It's always X equals that number right there. Am I going to have a max or min this time? Max, because my parabola is down. F, the y-intercept. Okay, this one's a little bit trickier. It is not just automatically going to be 0, 4, because that's not C. That's K. That's always the Y coordinate of your vertex. So here you do have to plug in 0 for X and actually compute a number out. So I'm going to plug in 0 for X, and I just have to do the math. So if you plug in 0 right there, 0 minus 4 is negative 4. What's negative 4 squared? 16 times negative 2? Negative 32 plus 4 is a negative 28, I believe. So way off my grid, so it's not going to help me as far as my graph is concerned. But that's where this thing would cross the y-axis. And then G, I just got to graph it, right? Okay, I didn't even put the vertex on here. 4, 4. There it is. But now, graphing is just like it was, just like I did before. It's just my original equation is a little bit different. So just be careful when you're plugging things in. So you tell me, what would the next number be that you plug in? I would plug in 3, right? Because you're either going to plug in a 3 or a 5. So why not plug in 3? It's smaller. So everybody take a minute and plug in 3 and see what you get out. The original for X. Did you get an answer? When you plug in 3, what comes out? 2.
No. I got negative 31.
I got negative 2.
I think it should be positive. So let's go back and check. So this is yeah. These are going to be the parts where we mess up if we're going to mess up at all. So we got to be careful here. So if I'm going to plug in positive 3, 3 minus 4 is negative 1. But what's negative 1 squared? Isn't it positive 1?
Yes.
Yeah. So 1 times negative 2 is just negative 2. And negative 2 plus 4, positive 2. 3, 2. Mirror that over. Buy 1, get 1 free. Buy 1, get 1 free. Now what number are you going to plug in? What are your choices?
6 and
2 or 6. Does everybody see where I'm coming up with those numbers?
2. Yes.
All right, so I would plug in 2, right? It should be easier. But you can plug in 6. It doesn't matter. You're going to get the same answer out. So you do what you want. Actually, plugging in 6 might be a little bit easier for some of you because it's less negatives.
So you get negative 20.
I didn't.
How? Vestavia, what? Can you show us what your...
I got negative
Yeah.
4. Please.
So when okay, did you plug in 2 or 6?
You plugged in 2.
All right, let's plug in 2. 2 minus 4,
Why-
negative 2.
Why are you doing 2 minus 4 first? Why are we squaring it? Oh, I see.
Don't you do what's in parentheses first?
Yeah, you do. I don't know why I make that. Wait, let me do it again. 2 minus 4 is negative 2. Negative 2 minus 4 plus 4. Negative 2 minus 4, negative 6 plus 4 equals negative 2.
You had a negative 6 somewhere in there that you shouldn't have. It should be a negative 8.
Negative 2 minus 4.
You're plugging in a positive 2 right there, right?
Yeah.
2 minus 4, and negative 2 squared is,
4
so 4 times negative 2 is
plus 4.
negative 8.
Wait, go back.
4 times negative 2. Yeah, you're multiplying. Negative 2 times whatever this answer is. And that answer we just said was a 4.
So -8
Plus 4.
4 equals -4.
Yes. So, 2, negative 4. Mirror that over. And it makes sense, right? It falls in line with the rest of my pieces. Everything looks good. I am going to show you guys or maybe has anyone picked up on a pattern yet? Have you noticed something every time we do one of these graphs? Have you seen something happening?
Is it about the points that fall in the x-axis or like straight lines or not?
Okay, I hesitate to tell you this, but I'm going to tell you this because it's going to make your life so much easier. Are you ready? Are you listening? Because this is like, I don't know.
It is knowledge.
But I mean, it's a pattern that holds true, so why not use it? All right, you ready? Okay. You have your vertex. You find your vertex like you always do. Whatever A is also tells you how to get to your next point after your vertex. If it's negative 2, I go down 2 over 1.
Yo.
That only gets you your first point, though. Notice, I don't go down 2 over 1 again. Whatever this number is, that's how you get from your vertex to your next set of points.
And then you don't have to do the first thing, and then you can just equate the others. Oh my gosh, you're my favorite. Okay, wait.
Now, well, let's go, and this is for the other one, too. So go back to, where's the other worksheet? Because I want you to know how to plug numbers in properly. Because you need, oh, here it is. So if I just see, does this hold true over here? Yeah, it does. Look. Here's my vertex. And then what was A in this one? 1. So I go up 1 over 1. Up 1 over 1. Yeah, it's whatever that is. It just tells you how to get to the next 1 point. So if I look at, okay, look at number 2 here.
I like the gopher. So I wrote this.
This one, I had my vertex. And then A in this case is negative 1. So I go down 1 over 1 and mirror it over. You follow? What happens when it's a fraction? Please pay attention because this messes kids up all the time. Look at this fraction one, right? Please watch because I don't want you turning this paper in with this wrong. Are you listening? Is everybody watching? Watch. This one's a half. It's not like slope that means that you go up 1 over 2. It's up a half over 1. So look, I went up a half over 1. See if I drew my parabola a little bit better. If you go up 1 over 2, you'd be over here, and that is wrong. So fractions still work. It's just you're only going to go up a half a box over 1. Or if it was a third, you go up a third of a box over 1. If it was 3/4, you go up 3/4 of a box over 1. You can only ever go over 1. So if you're trying to go up 1 over 2, you're already doing it wrong. So when I go to do number 6, once I find out where the vertex is, so watch this. All right, vertex in this case would be at 24, negative b over 2a, negative 6. So it's a negative 4, comma. So then that would be 16 times negative 3 minus 24 times negative 4 minus 49. This one has a vertex at negative 4, negative 1. But then to get to my next point, watch. If that's a negative 3, I can just go down 1, 2, 3 over 1. Buy 1, get 1 free.
Can you do that for the next?
No. There is a pattern for the next point, but it's not nice, so I would literally, you're better off just plugging the number in.
So could we, for number 1, can we do that? Because I think I got the point, but like, I'm not sure.
I think on the original paper.
It doesn't matter. It works for either one. I was just showing you ones on the old one. So, there's my number 1.
Oh.
I connect it all with a nice smooth curve. So let's try this with, let's do it with 3, since that one's a little bit different. So, just look at this and tell me where the vertex is. Well, okay, let's go back. Is it up or down? Up. Is it wide, narrow, neither? Neither, because A is just 1 here, so it's not going to be particularly wide or narrow. C, vertex. Here, you can just look at this and tell me where the vertex is. There's no math to do. -2, comma 2. It's always the opposite of the number in there with the x, comma that number. If we're in vertex form, which we are on this sheet, I don't have to do any math to find the vertex. So now, watch, using this trick that I just taught you, -2, 2. If A is 1, where's my next point? Yeah, it's a positive 1, so I just go up 1 over 1. And then I mirror it over to the other side. There is a pattern worth knowing for when A is 1, because you do, when you graph graphs when A is 1 more frequently than any other one. There is a pattern. See how, okay, I went up 1 over 1. The next one is going to be here. Does anybody know? Can you see? How did I get from... Look at all your ones when A is 1. Do you see a pattern? How am I getting between the points? Besides going up 1 over 1 to get to the first point. Look at some of the other ones that I graph when A is 1. They all follow the same pattern. Yes. It's just when A is 1, it's actually just the odds. You go up 1, you go up 3. If you want to keep going, you would go up 5, you would go up 7. That's it. Pretty interesting. So now, anytime you have to graph something when A is 1, oh my gosh, if you know the pattern, you can do it so quickly. Watch how fast you can graph number 5. What's the vertex? -2, -1. And then since A is 1, I go up 1 over 1. And then up 1, 2, 3 over 1. Mirrored over. That's it. Oh my gosh. You can still plug in points if you want. But if I know the pattern, it's actually a really good idea to at least plug in one of these points and just make sure that you're right. Because what if you had accidentally messed up the vertex? Yeah. That's just the pattern when A is 1. You always go up 1 over 1 for the first point. And then the next point's up 3 over 1. And if you did another, it would be up 5 over 1. That only holds for when A is 1, though. That's not true when A is 2, when A is a half, when A is anything else. It's just when A is 1, the pattern is 1, 3, 5, 7, and so on. The pattern does always hold for the first point being whatever A is.
Wait, is it up 3 over 3 or up 3 over 1?
It's always over 1. So from the vertex, you go up 1 over 1. To get my next point, from that point that I just made, I go up 3 more over 1. So go ahead and try and graph 6 for me super fast. Because there's another one when A is 1.
Wait, can we go back to 5 real quick?
Sure.
Get the vertex, where do you get the -2 from?
It's always the opposite of the number in there with the x.
Can you, like, word that so I can write it down?
I don't know what I would say besides that. It's the, maybe rewriting the formula would help? I don't know.
So you just take the opposite of H and then K, you leave K?
Right. K is whatever sign it normally is. You just leave that as it is. Did everybody graph 6? Graph 6, knowing what you know. Oh my gosh, you just unlocked everything on quadratics. You can look at, there's not even any math to do to graph this thing anymore. Holy moly. Cannoli.
Is it supposed to be like tiny?
Is it supposed to be tiny? No.
No. It's supposed to be that.
Oh,
Where's the vertex on 6 going to be? 1, 2. 1, comma 2. And then, because A is 1, and I know the pattern, I can do the rest of my points without having to plug them in. If you forget the pattern, just plug them in. I mean, you can always fall back on that. But I know if A is 1, that means I just go up 1 over 1, mirror it over. And then I also know from that point I just made, I can also go up 3 over 1. Buy 1, get 1 free. And isn't it everything you ever thought it would be? It's up, it's not wide or narrow. It's beautiful. Gonna connect that with a nice smooth curve.
so we can grab 2, 4.
Yeah, so let's say you're trying to graph number 4 now.
Oh, we can grab every one of them.
You can graph all of them.
Ah. Math for scrubs.
Oh, okay. So, where's the vertex?
It's -3, -3.
-3, -3. Correct. -3, -3. And then, how do I get my next point? Down 2 over 1. Buy 1, get 1 free.
Why 2?
Because A, in this case, is a -2.
Oh yeah.
We don't know the pattern for 2. There is one, but you're not going to remember a pattern for every single one. It's crazy. So, to get my next point, just plug it in. Would you rather plug in -1 or -5? All right, plug in -1. Shouldn't be too bad. 4. See if whatever you get makes sense with the graph.
Makes sense, it's just not on.
Are you sure? It is.
I got -11.
And that on your graph for number 4?
Oh wait, I thought you meant to count 11.
Oh, no. That's just an ordered pair. So -1, comma, -11.
Oh.
And there's the graph looking just like I thought it would look. Down like a frown, narrow, connect with a nice smooth curve. Not bad. So, what do we think? These are okay? And now we've been skipping around. We haven't been saying all the things that we need to be saying. But could you answer them for me? Like, I don't know. Let's go back for number 4. 4 obviously is down. Is it wide, narrow? Neither. Narrow. You already showed where the vertex was. -3, -3. What's the axis of symmetry? X equals -3. Max or min? Max. And where would the y-intercept be on this one? It'd be at 0, comma, -21, you say? Then that makes sense, because I know, look at where I'm at. I know it's going to be some negative number way down here, right? So it's going to shoot down. I would just have to plug in 0 to do my math out. But -21, that sounds right. And then G, my graph is there. So you guys could answer these things for all these graphs, and you could graph them all? Even the ones on the back?
Yeah,
Do you want to do one fraction one together?
no.
Sure, let's do 7. Now, I'm just going to help you start off graphing it. Where would the vertex be? 4, -2 is correct. Go ahead and plot your second point. Well, second and third. Put them where you think they go. If you're going to use the pattern. Okay, did you plot them? If you put a point at 6, -1, you are wrong. You cannot do it that way. That's not how the pattern works. It's not like slope.
Do you mean 5 -1?
No, if you put it at 6, -1, you are totally wrong. I guess 5, -1 is wrong too.
How would you even get that?
Here, because they're gonna do up 1 over 2 like that, and that's not what this means. The pattern does not work that way. It's always over one box. So this is up 1/2 over a box. It's right there. So if you plugged in 5, you should have gotten out -1.5. That's the right point. Buy 1, get 1 free. So fractions are a little bit more of a pain in the neck to deal with, but at least you get that first point for free. As long as you know what you're doing it right. Whatever the fraction is, you go up that fraction of a box over one box.
And this one's gonna be wide.
Yes. Now, if I'm you, I'm going to plug in 6 or 2 and see what I get out. Let's plug in 6, because that would be kind of nice. 2 squared is 4. Half of that is 2. 2 minus 2 is 0. So when I plug in 6, I get out 0, and I can buy 1, get 1 free back over here. And there's enough points to make my beautiful parabola.
That one's not that wide.
No, and a half, the closer it is to 1, the less wide it is. Like if it's 3/4, you're barely even going to notice that it's wide. The really wide ones are going to be like 1/9, 1/12. Yeah, the closer it is to 0, the smaller the fraction is, the wider it gets. But yeah, it's hard to even notice until it's less than, the one's less than a half usually.
Y-intercept on this one?
There's always a y-intercept.
It's really cute.
It's just going to be probably some positive number. I don't know what it is.
Tell us.
I don't know it. I can figure it out.
Oh, you have to.
6. Yeah, you just plug in 0 for x. But I do believe it's a 6 that comes out, which makes sense, right? If my graph kept going, yeah, it's reasonable that's going to cross at a positive 6.
What if there's a negative sign, like for the parentheses? Would that be a negative 4?
So on like number 9, you're going to graph -4, 1, and then go down 1 over 1 for your first point. All right, guys, what do you think? Everybody's okay?